Hello, and welcome to the National Spectrum Consortium Spotlight Series. I'm Sal D'Itri. I'm the chairman of the consortium. Today, we're recording with a group of experts from member company Cisco Systems. Now, let me introduce you to our panel. We've got Craig Hill, who's a distinguished architect, Mike Geller, who's a principal architect, and Kevin McFadden, who's a business solutions architect, and Joe Beel, a senior defense strategist. Our theme today is Zero Trust, something so critical today as we're looking at 5G and wireless network rollout. Guys, thanks for joining me.
Thanks for having us on, Sal.
Before we dive into today's theme of Zero Trust, take a minute each and tell us what you do every day for Cisco Systems.
Hey, Sal, how are you? Craig Hill, thanks again for having us, bud. So I'm a distinguished architect out of the U.S. Public Sector CTO office. I just hit my 25 years here at Cisco. And like all of us, I have a very core foundation of routing and switching capabilities, but I've really transitioned also to some of the newer trends and some of the things driving our customer requirements, things around software-defined anything, really. Software-defined WAN has been a big focus. The transition to cloud networking and how we're moving our customers there, high-speed encryption, as well as automation programmability. And then, of course, 5G. And one of the key areas of my role, though, the most important, is really talking to customers of all levels, whether it's the CXO level, network operators, and really understanding their requirements, their business requirements, and then taking those requirements, back to Cisco, back to our product development solution architects, and creating solutions that help their business. So that's really what my focus and role is.
Great.
Cool. So that makes me next. Hi, everybody. My name is Mike Geller, and I am a principal architect in the security business at Cisco. I've been here for almost as long as Craig, 23 years, and my focus really is on mobile security and security in the service provider, cloud scale, web scale realm. Now, insofar as that's the case, I've had the luxury and the honor of creating a 5G security platform architecture, analysis of threat surface, kind of set of best practices and other material oriented around taking our customers into this 5G space. Like Craig, a vast majority of my work is also done facing customers. Creating academic ideas are good. Creating ideas that solve customer problems are a lot better. And 5G brings a lot of challenges with it, and we'll talk about those later. My job is to make sure that you can have a method and a security stack that you can apply to 5G that starts with trust, which is so foundational to the conversation we have today. So I'll pass it to Kevin.
Thanks, Mike. So my name is Kevin McFadden. I'm a business solutions architect here in our federal sales team. Actually, Craig and I are colleagues, so we're cut from a very similar cloth. In fact, I've actually been here at Cisco for about 20 years as well. So, we've got the 20-year crew here. But, throughout my career here at Cisco, I've predominantly spent time working with our public safety, law enforcement, homeland security as it came about after 9/11, and our Department of Defense customers. And most of those efforts were around how do we help them be more successful in the field, in mobility and wireless, and being able to ensure that those applications are secured to the proper level and available to them in times of need. Joe, back to you.
Hi, everyone. Joe Beel here. I develop and implement strategies for the U.S. Department of Defense where we leverage Cisco's commercial capabilities to solve the DoD's problems. I'm retired Navy. I served in command in Naval Air Systems Command and Space and Naval Warfare Systems Command, now Naval Information Warfare Systems Command. And I've been with Cisco for about 6 years.
Well, with so many 20-year veterans, I'm surprised I'm the only one with a gray beard. Life at Cisco must be good. Guys, let's go ahead and jump into Zero Trust. Joe, why don't you kick us off?
Thanks, Al. We're really excited to be here. We hear a lot about Zero Trust these days, and what's changed that made Zero Trust important, and why is it so critical for 5G? So, Kevin, I'll start with you. What does make Zero Trust so important, and how does Cisco approach Zero Trust?
So great question, Joe. And you're right. There's a lot of opinions going on around the industry right now about this. Zero Trust at Cisco, we try to think about it in three terms. It's about the workforce, the workplace, and the workloads. Within those categories, we start with the idea that there is no implicit trust. We throw out the idea that implicit trust is inherent. Start with an idea that based on who you are, or your identity, and what your intent is in your job function or job role, we will assign you, based on those criteria, a capability and a posture within the network or in the workplace such that you can get access to the workloads and the applications that are appropriate for you. And so part of this is being able to identify the right work groups, be them, a macro version of this could be a situation where we're identifying humans versus machines, and then being able to, within those categories, be able to identify what they're able to accomplish. We're also layering on technology like artificial intelligence and machine learning to be able to help us rapidly move at the speed of machines to identify both trends and normalities versus abnormalities, and be able to quickly move to remediation or to prevent attacks accordingly.
Thanks, Kevin. So, Mike, given that approach to zero trust as context, what's different between security in 4G and 5G? And is there something different about 5G that makes zero trust absolutely essential in any discussion?
So I'll start out by giving 3GPP as a standards group a lot of credit. They actually have taken a number of areas specifically having to do with the RAN and with other parts of the 5G network and added in both cryptography as a method of assurance and other techniques in security that we'll talk about through the talk today to deliver a more secure standard outcome. Now, what's different about 5G is that 5G is about use cases. These use cases might be in the secure DoD environment, battlefield implementation, or whatever the case may be, in a completely private implementation, or it might be a hybrid where there is a connectivity between a private implementation and a public one. Regardless, those use cases go from everything like enhanced mobile broadband to connected car to connected healthcare to gaming to virtual reality, anything with an ultra low latency, high speed reliability, experience. And again, 5G is about the user experience. I don't know how many of you have kids, but my kids will wait about 5 seconds, 7 seconds before when they go to look at a website and try to consume an outcome. And if they can't get it, they move on to something else or something better or something different. So there's a lot of pressure on us to deliver those use cases reliably and in a very widely distributed way. And 5G, in order to do this, we push portions of the network rather than be centralized like 4G in a very distributed way, extending our fabric, our telco cloud, our cloud native aspects, our automation out into an area we call mobile edge compute. We push the user plane function out toward the closest proximity as possible to reduce that latency to the customer consuming the service. And there is a set of security outcomes that come with that distributed architecture. So really, in essence, 5G security is all about all of the security challenges, the security process, the basics around visibility, around segmentation, around properly placing the controls in the right place, and around always learning, kind of an iterative process. It's about taking what we do in 4G, expanding to the new components that make 5G work, cloud native and automation and the like, and catering to the security and threat surface that comes about in that widely distributed delivery of the 5G service.
So, Mike, with this disaggregated and distributed architecture, how do you go about providing a zero trust architecture that addresses all those elements in that distributed architecture?
Very carefully. So there is, I will start my answer here by saying that 5G is delivered in two flavors today. What we call 5G non-standalone, which sweats the control plane assets from 4G, leveraging some of the new radio and some of the other components of 5G that allow us to have a 5G augmented service set. And then there's 5G, so that's sort of taking the old, sweating the assets, and bringing what we can for 5G. 5G standalone is about a completely reconstructed way to deliver the 5G outcomes, which brings the agility, the automation, the widely distributed nature of cloud native delivery of a service set of microservices in containers orchestrated around Kubernetes, pods, and the like, and having all of that encrypted. So when you talk about zero trust, there's zero trust, as was mentioned by my colleague earlier, of the actual workloads themselves. So I need to look at how I'm going to get visibility in those workloads while those workloads are encrypted. So I'll need to be very close to the actual workload itself to be able to get that visibility before things are encrypted. So then I can have my security controls both identify anomalies, do something about them, and learn from that activity. So you then have this aspect of trust in the network that runs the 5G outcomes. You need to be able to trust the routers that run in the back hall and the front hall, and the compute that runs at the MEC, and there's this whole stack of trust and the ability to keep track of things like runtime attestation and understanding what a device is 3 weeks after I deploy it, making sure it still is what it said it was. Has the software been modified? Has the configuration been modified? So there's this entire level of trust that goes with operating a packet core from top to bottom in what we're going to talk about later that's called a slice. And so zero trust means a lot of things to a lot of different people. In the end, it's about taking this group of best practices that we have and that are evolving for 5G networks and adjusting them to make sure that our outcomes are delivered quickly, that our outcomes are delivered reliably, and our outcomes are delivered securely.
Thanks, Mike. So, Kevin, we know from data like Cisco's annual security report that typically our customers are going to have 5 to anywhere as many as 50 on average different vendor security products working together in their architecture. So what do we do to make sure that these products can work together, security and networking and multi-vendor products, to give an environment that enables zero trust to have things working together?
So it's, Joe, great question. It starts with an open environment, an open API environment in most cases, where we have an ability to use those APIs to interlink the products together. And it's about multi-vendor, because in many cases, there's not going to be one source. There's going to be a portfolio of capabilities. So part of this here at Cisco, one of the examples I'll give is a technology called Pxgrid. It's an open standard, scalable IETF architecture designed for data-driven sharing and threat control. And it's really, if you look at, let's take, for example, things like identity management or threat intelligence, and how you actually map those to things like policy enforcement, leveraging advanced technologies like artificial intelligence and machine learning to be able to create or identify trends, and then be able to create automated policies to be able to respond. Pxgrid is the means to be able to tie all of those various technologies, not only from Cisco, but from other parties, and be able to bring those together into a wealth of knowledge. So it's about situational awareness, it's about collection of telemetry, and be able to initiate actions, either human intervention or automated actions that can then move the system in a very consistent and cohesive way.
And Kevin, if you need something very specific to be created that doesn't exist already as a product, you can use Pxgrid to integrate something custom built?
Absolutely. It's an open architecture. So as long as you're complying with the standards, a new vendor could come along and very easily add to an existing platform or capability. And so that's the real benefit of open APIs, is the ability to allow it to expand as the ecosystem grows.
All right, great. Thank you. So, Craig, there's a lot of discussion about the promise of increased speed with 5G. So what capabilities from a security perspective come into play so that they don't degrade the speed advantage of 5G, and how can these security capabilities make a difference in a 5G architecture?
Yeah, Joe, it's almost, two contrasting requirements, right? I want it highly secure, but I want it fast. And up until recently, it's been a challenge. And just to give a little background, when we think of network security, network security is always thought of with IPsec, and we've used IPsec for many years. And what we really hit was with IPsec is that IPsec there was a contrast where we had IPsec and then we had link speeds. And link speeds through IEEE, 10, 40, 100, we're up to 400 now, we'll be seeing 800 in 18 months. The encryption of IPsec has not been able to keep up with those rates of actual how IEEE has been driving these link speeds. And voila, we introduced IEEE 802.1ae, which is max security, or referred to as Maxsec in the industry. And one of the things that Maxsec gives us the ability to do, while Ethernet has become incredibly predominant both in data center, campus, as well as WAN, we've actually leveraged Maxsec now to bring that down to layer 2 to do the encryption. We can go up to AES 256 GCM at the data plane, and now we get a match of encryption rates with the link speeds up to 400 gig, which you will see this calendar year. Now, if I bring this back to 5G, this has been a huge advantage for us, because in the 5G network, as already mentioned, Mike and Kevin mentioned, even in the RAN, we're disaggregating certain elements of the network. And if you think of the 5G architecture as a whole, we've got the towers, but then we go to the RAN, and we can break the RAN up now into front, mid, and backhaul. We go to the IP core, and then we take you back to the mobile packet core in a centralized data center, which may be where the centralized UPS sits. And for us to be able to leverage any of those rates in that infrastructure of 10, 40, 100, and then 400, and use Maxsec to secure it, we're giving ourselves that underlying security we need. And then I go back to even what Mike mentioned with 5G, leveraging, for example, slicing, where the network will be an element of slicing. Maxsec will be transparent to any of the requirements of segmentation, however we do it, hard or soft slicing. It'll be transparent, to that infrastructure while giving us the security that we need. So really, really powerful. It's out there today. Customers are leveraging this today, as well as mobile packet core providers, as well as the cloud providers.
Great. So Craig, Mike alluded to trust in your underlying infrastructure, hardware and software. What does Cisco do to help start with a trustworthy and secure foundation, both from the hardware and the software perspective, and particularly as it relates to 5G?
Yeah, it's a fantastic question, and like I did before, I'm going to start with kind of where we are and bring it back to 5G and how we truly can leverage it. If you look at network security, and we're all going to talk about it today, we really look at it holistically, and that's how you have to look at it. It is absolutely not a box approach. So looking at security, the before, how can I secure it? How do I deal with issues during? And then how do I deal with issues after? And if you look at some of the ways we're going after what a framework we call Trust Insights, and there's multiple components to this, the first being the trust anchor, the idea that when a device comes online, I want to make sure that that device truly is what it says it is. And we have embedded capabilities with our trust anchor modules in our hardware, as well as our virtual network functions for software, as you mentioned, like in an NFV type of world, where we can actually leverage and say, hey, look, I want to make sure this is truly who you say you are. And we have digital fingerprints to go about checking that, as well as the ongoing capabilities where I can, at a certain interval, constantly check to make sure that, look, I know the device came on secure. Now I want to constantly maintain that it is secure and that it has not been tampered with during operation. We have abilities and attributes that we can constantly check securely through digital fingerprinting to make sure that exists. And the real key there is the old MTTK, or mean time to know. I want to know right away, immediately, not in days and weeks or hours, maybe even minutes and seconds. And that's really what we bring to the table here. And we've brought together those two with more of a system approach, more of a closed automation approach through really two key pieces. One is the trusted path routing capability. And then the idea that we brought segment routing, which is a very well-known standard in the IP backbones today, where we can actually look at a device being tampered with, for example, and then we have ways to make the network react to that. So, for example, if I don't know if I think the device is under, there's some anomaly happening, but I'm not 100% sure, I can take very mission critical or business critical traffic, move it off of that through sophisticated traffic engineering capabilities, and then leverage the trust path routing capabilities as well to divert that traffic. And what I would finish this with, Joe, is obviously this is going to be very relevant for the holistic architecture I talked about with Maxsec as it relates to 5G. And we bring this up to what we call, this dashboard of forensics called Cisco Trusted Insights. And that gives us the capability to direct the dashboard. It stores our keys. It's cloud-based, so we can leverage other things like Talos and other malware functionality, so we can leverage the network as a sensor for these capabilities. So that whole Trust Insights piece is way beyond what I'm talking about now, but we are focusing heavily on this right now, and it'll be very focused for 5G infrastructure.
Great. Thanks for those perspectives, Craig. Really goes a long way to help secure the network, particularly in 5G. But we know a lot of breaches are caused by human error, misconfiguration of devices, things like that. So what do we do that helps minimize that problem?
Yeah, I'm going to introduce this whole concept of just network automation, and you're seeing this very broadly in the industry. And we have I'm very passionate about this. I work with a team in federal that is passionate about this. We have a whole DevOps team, and we have this little joke where we say a network, should I say, a device without an API doesn't exist. So the concept here really is we're starting to see programmability and automation. And we're starting to see gains on that, but what we're really trying to do is take it to the next level. And that next level, Joe, for this is really moving it more towards what we call this whole DevOps approach. And the DevOps approach takes programmability automation, and it really introduces this whole simulation and test element to this. And the real key way to achieve this is through an industry, you're starting to hear this commonly in the industry, is this CI/CD pipeline, or this continuous integration, continuous delivery. And what this does is it takes maybe network adds, moves, and changes, where I would typically use a command line interface, or maybe even automate it, and go down to actually touch the device. The idea with this is that we run it through a simulation test phase first. And the idea of the simulation test phase is to emulate as close as possible to the existing network infrastructure. And then we run that test, and then when we get the okay for that, then we use automation programmability and open APIs then to program the actual operation of these devices. And we're constantly running through this pipeline, and this gives us the idea that we can build it, we can test it, and then we can deploy it. And we call this hands off the keyboard, for example, Joe. And the idea is, as we know, more hands off the keyboard, less human errors, which is still probably 80% of the network errors we even see today in the cloud providers and service providers. And it also, on the flip side of that, while we reduce the errors, it allows us to roll out, or customers and cloud providers and service providers to roll out services quicker in a more efficient way, and knowing that they've been simulated and tested in this environment. And look, this is really the path moving forward to rolling out services quicker and reduce, as you pointed out, those errors. And this will be a big piece for the 5G infrastructure, because we have so many components. There's an open ecosystem, so we have multiple vendors as well, so the open APIs will be key. There for us, it'll probably be Yang models to start, and that's where we're really going now. But that's really this whole CI/CD pipeline, and this move to DevOps is really going to, we think, take us there and get us to where we need to be.
Great. Kevin, so Craig talked about DevOps, programmability, API. Could you just take a minute or so and summarize the tie between software-defined networking and these advances that Craig's talking about, and a zero trust architecture?
Sure. So, it comes back to what I was talking about earlier with APIs. Part of this is using Pxgrid as an example really ties the infrastructure together. And, at the end of the day, it's about the things that Craig talked about, programmability. So if you think about the enterprise, you think about mobility, things like cellular technology, today, those technologies are starting to evolve where there are controllers in each of those environments that are able to help us in this software-defined world where we're using identity management and being able to apply policy based on who you are, what your job function is. We're going to see the need for that move into the cellular space and extend into the mobility of cellular applications. But tying that all together into a zero trust architecture is the ability to identify situational awareness, be able to apply policy, and be able to remediate or defend against attacks based on these APIs. So it's about consuming telemetry and being able to do something intelligent with that telemetry to be able to respond. It goes, Joe, this goes back to your days in the military with the OODA loop, about being able to collect the right information, be able to make decisions, and then execute on those decisions.
Right. So there's also a promise of massive IoT devices in 5G. Industry 4.0, so in the DoD, things like shipyards, aviation depots, very industrial environments. So how will we approach zero trust around 5G in these types of environments?
So I think zero trust is going to be about being able to know these industrial use cases better than we do necessarily today. Part of that is situational awareness and telemetry, but it's very specialized telemetry, being able to bring tools like Cisco's CyberVision into focus. These tools are designed to be able to understand the industrial protocols, things like Modbus and other things that are in controlled systems today, sometimes very closed systems, and be able to either adapt those to carry them over IP and over things like 5G, or at a minimum, at least be able to understand them in their native environment and be able to identify how they're behaving, whether they're operating in norms or abnorms, and also identify, of course, cyber attack. Many of these systems are in very critical systems, critical infrastructure, control systems, and so they become a very sensitive area of the infrastructure. Very important that we understand what their, again, normal capabilities are, what their abnormals are, and then be able to respond quickly to anything that's out of the norm.
Thank you. So, Mike, pulling on your security CTO office role, what do you see coming next for security, particularly in 5G?
Good question. So, we're looking at security almost like I'm being asked to secure the plane and make it fly as we're building it. And 5G outcomes are still growing, especially in terms of standalone cores and cloud native delivery and the like. So there are a few things that come to mind that I would say. I gave credit to 3GPP from a security perspective because they've really taken some forward-looking stances in some critical parts of the network. Some of the things that you're going to see, for example, in 5G standalone, we have the service outcomes for the packet core are going to be delivered as groups of microservices, sequences of them, delivered inside of Docker containers, inside of Kubernetes pods, and having those outcomes, that service chain, encrypted. So the way that we're not just dealing with encryption, as was mentioned by my colleagues earlier today, around the actual transport part of the network, but you're working with encryption in terms of at an application level and where you need to be in the network to get visibility. So you can remember that in security, to have any security control work, you generally need some kind of visibility, so I can baseline normal working activity, define an anomaly either by a signature or a behavior, and then take some action. Well, if all of that traffic is encrypted, I have to then figure out a way to get very, very close to the host operating system that's hosting the containers and that's hosting those microservices to be able to get proper visibility. And we're, as an industry, working towards agility in that way. We have to better understand the threat surface of cloud native environments as they are coming into mass production these days, and that's work underway. I talked a little bit about crypto. Now, as we tend to proceed, we're going to move toward stronger crypto algorithms, maybe from 128-bit AES to 256-bit AES in the 3GPP kind of framework and in the application of delivery of these services. And as things like quantum computing come along and give us different power and agility related to cryptographic algorithms, I think we're going to find some movement in 5G on the security front, kind of in the what's next mindset of how we actually deal with crypto at different places in the network, not just for fixing things like IMSI snooping and other threats and vulnerabilities that were in 4G that have to an extent been addressed in 5G. But how we detect rogue nodes attaching to a 5G network, what we do with that information. It was brought up earlier by my colleague around the proper use of telemetry. Well, if you from an SDN perspective, there are many SDN components that fit to the 5G security infrastructure. Because everything is so widely distributed now, we have to look at application protection, denial of service protection, signaling protection, and a string of security services at the edge and throughout the fabric, everywhere in the network. And when we go ahead and do that now, in order to achieve that kind of a scale, I need to have a centralized control, or as was called out earlier, a controller. So there's going to be controllers that handle different security functionality, and they need to be made to work together. This sounds like a lot of complexity, but these things rest on best practices for things we already do. The only other thing I would call out in what's next is a keen focus on segmentation and slicing. So we're just now starting to see things like slicing or properly segmenting the entire stack of the 5G delivery into zones so I can properly secure them and make sure that a nefarious actor in one zone is not able to do anomalous things, criminal things in other zones. So the whole science and operational best practices around how a slice is created and how that interacts with enterprises when I do need to have a public and private persona for the 5G will matter.
So, Mike, we'll see the use cases, desired user experience, cost efficiency, a bunch of different factors drive towards a heterogeneous network of various types of wired, wireless connectivity. But in particular in 5G, how do we securely handle the interface between, say, public 5G and private 5G?
Good question. So this is completely use case driven, but it also rests on best practices that we've been using for years. So look, in a private 5G deployment, be it a IoT-based situation where I'm in a manufacturing plant, might have a hybrid 5G Wi-Fi 6 deployment controlled accordingly, I'm going to treat the security of that very similarly to how I secure applications today. I get visibility, I segment them accordingly, I define anomalies, I apply in an automated way the security controls I need, and I consistently go and learn. I have people, process, and tools to make those things happen. Now, many cases, be they civilian or DoD, will involve a completely private application, both from the spectrum side to the actual infrastructure that runs the 5G packet core. Great. So we're going to apply a lot of what we've already talked about today and some of what we already know about how to secure our enterprise applications to that focus. Let's now move the focus a little bit to where I have an application where I have a private deployment, but it needs to actually interface with, let's just use the word public to refer to 5G running a service provider. So in that case, there are a number of personalities that need to be taken care of. One of them is, how do I take identities? So there was talk earlier today about Pxgrid and Identity Services Engine and different methods that Cisco can use in an open way to articulate an identity outcome out into a consumer of that outcome. In other words, a slice in the 5G network, so I can have a continuity of that private aspect from the enterprise into the public network, maintaining a consistent identity and security profile. Now, there's another hour or two of conversation about how that actually gets done, but know that it's happening and we're working toward it at this time. The other thing then, alongside with that, having an identity-based capability, is having a policy that might be unique. So what that means is, if I onboard a device, if I use automation to onboard a device, whether I happen to be on my enterprise or I happen to be in the public 5G network, I want to be able to have consistent ability to apply policy to that device. Now, and we're doing that and working on that in real time, connecting a slice to an enterprise policy from the perspective of standard policy definitions to policy models and the tools that will make that work. Now, one last thing that I'll point out is that today we have, security is a cool field to be in, because every time you look at something new, you apply something you already know to fix the problem. You just need to be agile and creative about how you do it. So one such example would be application layer VPNs. It's very common today that I pick up my phone, I have a priority or a policy associated with my identity, associated with specific applications on my phone, on my PC at work, on my laptop, whatever it is. And I want to be able to now have a ubiquitous policy that will be across the 5G components publicly and the private components. So what we're doing is a per app VPN type service that leverages SD-WAN, leverages an identity and policy-based aspect of the application, and an integration into the 5G infrastructure, and candidly, even the 4G infrastructure, into things like PCRF for policy. So I can, in the end, have that single cohesive tie to connect them together. So you asked a very simple question, and as is usually the case with 5G, there's a number of layers, but that's how we go about it.
Yeah. Thanks, Mike. So Kevin and Craig, it seems like there's a lot of potential for 5G. It's a very deep discussion, as Mike pointed out. But what if an organization says, hey, I want to bring 5G into my enterprise? What would you tell them in a minute or so? How do they get started? And what are the key foundations necessary in their approach to have a solid approach to security for what they're going to do?
Yeah, so big question. We'll try and keep it short. Really, from a business architecture perspective, business strategy, it starts out with the business vision, the strategy itself within the business, and mapping that to current capabilities and where they want to go. So it's sort of like an as-is to a to-be discussion, Joe. And really, it's trying to map the use cases to the right wireless technology. Today, we have a great number of options available to us, things like cellular, 5G, Wi-Fi 6, even some technology we won't talk about here, but long-range, low-power technologies that could have a significant opportunity to transform and digitize our business capabilities. So, while we're talking a lot about massive bandwidth and low latency, ultra reliability, massive devices, it's that mapping of those various characteristics to the business requirements. That's step one. Step two is to look at the spectrum that's available. In many cases, that's going to be the biggest bar to entry. Is it licensed spectrum? Is it dedicated to me? Do I share it? What is my business impact if I can't get access to that spectrum, or I have to share that spectrum, and I may or may not be able to get my business done at the time of need? So those all come into play. Unlicensed spectrum, of course, is by definition a shared model. So how do we map those to the business capabilities? The other piece is security, as you mentioned, zero trust. When I look at zero trust, and my colleagues do the same, we look at it from a confidentiality perspective. And we talked about encryption quite a bit. That's very important to ensure that my information isn't accessible by unauthorized people. But it's also about reliability. and ensuring that my system is available at the times of need, and that, it doesn't matter if it's encrypted if I can't get it to the end device or the application is not satisfied. And then what is the impact on my business at the end of the day, and what can I afford to acquire in those spaces? So hopefully that gives you a reasonable number of the parameters at the top end of this. Maybe Craig, could you finish it off, and
yeah, Kevin, you and I are so tied at the hip these days. I think we can finish each other's sentences, so I'll make it very quick. Look, to your point, security is inherent in everything. I couldn't agree more with that. And whether it's at the link layer, like I was talking about, all the way up to the endpoints and the overlay and everything in between. Another really important piece, and we both mentioned, all of us mentioned, was the idea of just open APIs. This disaggregated network that 5G brings to the table, as well as the virtualization capabilities that 5G brings to the RAN, packet core, mobile packet core, et cetera. The idea that we're going to have an end-to-end visibility, end-to-end programmability, probably with different vendors and different type of components. The open API, specifically to security and zero trust, is going to be incredibly relevant, not only just to configuring the devices, but also the streaming telemetry aspect, so I can get an end-to-end visibility point of view of this as well. And I just want to echo your use case driven at the end of the day, and that integration of existing with new, and we have to make sure we do a good job with that. And as Mike pointed out, when we get private, we might need to have things a little more shrink wrapped versus public, but we really just need to maybe just to really work closely with the customer, what I would say, and really listen and leverage the use cases and multiple spectrums. The ability to use multiple technologies, like you said, is probably going to be extremely relevant. So but that's what I would how I would go about this. And Mike, I'll let you tie a quick bow on this. I know we're coming up against the end here, but I'll let you chime in to wrap this up for us.
Sure, thank you. So look, today, when I think about zero trust and its impact on 5G, I think about a number of things. It's going to be about a trusted user experience for 5G. People want their information faster. They want, and the people who are providing that information need to provide it as reliably and as they possibly can. They need there then will be a focus, as everybody has mentioned, on the use cases. The use cases are going to continue to influence not only in 3GPP from a standards perspective, but from an operational best practices, how we go about deploying these services with reliability and with agility. And the only last thing I would say is that you have to be able to trust the entire stack, and that's what's different in 5G. So when you talk about zero trust, as was mentioned, the methodology is I trust nothing. And I'm not just trusting nothing to the beginning from a router or the transport or the NFV fabric or the container or the application or whatever it happens to be. All these things come together as an outcome, as we mentioned in slicing. So, the connection of zero trust to mobile networks and 5G, be they private or public, is an imperative component for us to strategically think about when we bring and deploy services on 5G services privately or publicly. So I would tie it up there.
Well, great. Thanks, Joe, Mike, Kevin, and Craig. Thank you for really a wonderful, comprehensive, and a lot of great detail into a lot of these important areas of zero trust. I really appreciate Cisco Systems taking the time today to share this information. We're out of time for today. For folks who want to learn more about zero trust, feel free to reach out to Joe Beel at Cisco Systems. And thanks again, everyone, for taking the time and watching.